All right, we're almost to the end of this unit, and we've been working with systems and at times inequalities. So we're going to work with inequality systems and word problems. When we're thinking about inequality systems, remember that you're going to follow these steps. You're going to graph some inequalities. You're going to shade them lightly until you find out where the shaded regions intersect, and now you have a solution region. The only difference about what's happening right now is instead of your system being handed to you, you've got to read through a scenario and build your own system. Then you follow all those steps. So really none of this is new to you. I'm just doing a video to show you how it all works together. The scenario you read here is available for you on the lesson plans and on the notes, but go ahead and pause the video and read this so you understand what's going on. And the first thing we would like to do is take this and build a system of inequalities so that we can graph it. I'm just making this up, as you can tell. And do some light shading so that we find out where the intersection is between the shaded regions. So that's what we're going to do. We just have to go ahead and convert all those words into a system. So I'm going to show you what I've got here. I'm going to have it color-coded so that you see what words led to what inequality. I'm going to unveil the whole deal here. $2 for a paperback, $3 for a hardcover. So we want no more than $90 spent. So $2 per paperback plus $3 per hardcover better be less than or equal to $90 because he only has $90. All right. He also bought no more than 35 books. So the number of paperbacks he bought plus the number of hardcovers he bought better not be more than 35 books because he only bought 35 books. So from this set of words, I've built a system of inequalities. I'm using P's and H's. If that bugs you, go ahead and convert these into X's and Y's, and then you're in a little bit more familiar territory. So once you've built your system, your next step is to graph them, then shade lightly, find the intersection point, and then we'll have a solution region, and we can interpret what's going on with that solution region. I'm going to work with one with X's and Y's, and notice both of those were not in a Y equals mx plus b form. And if you don't want to graph by intercepts, then you go through the algebra steps to convert both of those into Y equals mx plus b form. So that's what I have right here. I need to graph both of those, and just so you understand which one is which, this is the purple one, and then I don't know if I have the exact same color here, but close enough. This is the teal colored one. So I graph both of those. They both have less than or equal to, so they're both solid lines. They're both less than problems, so technically I would be shading beneath that line, and I would also be shading beneath that line. So it gets a little complicated, but if I were to lightly shade those, the only spot where shading would have overlapped itself would be down in this compartment of the graph. So now we have our solution region down here. And it's important that you understand what's going on in the solution region. In this case, the solution region is saying any point in here, if I take the X and the Y and plug it into here, then I'm going to make both of those inequalities true. That's not going to be the case with any point I pick outside of that region. But since this is a word problem, those points also have a little bit deeper meaning. For example, here's the point 20, 10, and 20, 10 is in the shaded region, which means it's a solution. So what does that mean? Well, the 20 is representing the X, or this axis, so That represents paperbacks, since that's the x-axis. And the 10 is the y, which represents the y-axis, or my hardcover books. And so 20, 10 means it is okay to buy 20 paperbacks and 10 hardcover books. That combination of 20 paperbacks and 10 hardcover books satisfies the requirements of the scenario you read above. Basically, he can buy those and it all works. But if I take a look at 10, 30, and let me adjust this so I can get 10, 30 in there. 10, 30 would be out here. Okay. 10, 30 represents purchasing 10 paperbacks and 30 hardcover books. Well, 10 paperbacks and 30 hardcover books, not in the solution region, so it's an infeasible situation, or it's an infeasible event. Basically, 10 paperbacks and 30 hardcover books would not satisfy the constraints listed here in the words, or it doesn't satisfy these inequalities. So when you're doing these word problems, the only couple of differences is this. You've got to build your own system of inequalities by translating from words into math. And then once you have gone through the procedure of graphing and shading, any point from the solution region represents something physically from the scenario, something that would fit the constraints or be acceptable to the scenario. Any point outside the solution region represents something physically, in this case 10 paperbacks and 30 hardcover books, but it represents a combination that would not fit with that scenario.